Um, right, so as a reminder, what we've just done is we've used to workspace, and if I double click in, I've recorded the last 100 data points from that monstrosity of a curve. Now, once it outputs, let's close all these down. You'll notice it comes out here as out. Now it's just because if you look here, it's called out.acc, acc1, acc and acc1. So if I double click into out, what we get is acc and acc1. What I want to do is I want to try and start building a plot. I want to start taking a snapshot of just these. So I'm actually going to make my own variable. So first things first, I'm just going to make something called, I'm going to go new, and I'm just going to call this 20 deg run. Oh, I love you, MATLAB. So we're going to go 20 underscore, I will get there, 20 underscore deg underscore run. Now the reason I'm doing this, I'm just going to change that again. 20 deg run. How is that not valid? Right, okay. Deg run 20. Ooh. Right. So the reason I've done this is in here. I've been running at the same time step. So if I go into ACC, you'll see my last time is at 100. So what I'm going to do is left click on there. I'm going to copy. I'm saying that I might not need to. We'll put it there anyway, just in case. I don't think you really need it, but we'll put it there anyway. So I'm going to double click into here, and I'm going to paste. Right. There is a reason for this, because every time I run, if I run this sim again and again under different conditions, what will happen is it will overwrite the last data. So I'm going to use this as like a data log, if you will. So I'm going to go ACC, signals, values, copy, come back into deg, and paste. So my first line is going to be ACC, and then I'm going to close these down because I'm going to get myself confused. And then I'm going to double click into out. Oh, it's actually 10 degrees I started that. It's nasty. I'm going to ACC, signals, values, again, I'm going to copy. I'm going to come back to deg, it should be 10 actually. Right, and that now is the 2. So if I highlight these two and go to plot, ooh, what we got now is we got phase shift between the two, and you can actually see how it's reacting, and this phase shift could easily be accredited to the left and the right piston, which is fine. So you'll have like a lead piston, if you will, and then this one will naturally follow behind due to the balancing of it. These two are practically touching each other, and that's the point. So the argument is between these two, between these peaks, or between these curves here, is there a key considerable difference or not? And also, interestingly, you look at the curve as it rises, you look at the straight curve that's coming from it. This curve that rises is almost chasing this curve. This curve seems to be capturing any type of damping, and it's almost drawing that in. However, when the rolls are reversed, you end up with the same roll here as well, where the first piston is chasing the second one, and it's just the reciprocation process that's causing this. But my question is with it, is that if this is at 10 degrees, once you move up to 90 degrees, you'll get these massive changes where piston throw emerges. When it emerges, why is it emerging there? Why do we not have piston throw now? And if we have forces that are coming out, do these also get affected as they're going through? And you will find it. Now, you should notice, you've probably noticed, or I hope you've noticed, that this assignment is like a massive extension to the very first assignment that you did in year 1, which was the data set when you were asked to explain about the piston throw. That assignment I wrote based on this. I know it doesn't help. I know it doesn't help. But all I want you to do is run through them tests, run through them cycles, and see what you find. Are you going to find anything in particular? What do you think?
Okay, that seems a bit more reasonable to understand.
Yeah, well, it is, and as I said yesterday, I know I am murder for these assignments, and the only reason is I am forcing you to do the one thing that no other lecturers seem to have ever done for you, ever, and that's forcing you to make a decision. I know, a lot would say, well, I don't want to make a decision, I just want it to work. But this, I know it is quite time consuming, I understand that. And in one day, just sitting there, running these tests, extracting the force, extracting the acceleration, and pulling that position, so at least then you've got one thing to verify, to just show that your simulation's got some leverage within it. You do that, you show the equation that you've used, you do a plot to show what your version of it is, you do a plot to show what MATLAB's version of it is, and you kind of go, these correlate, which is fine, and then you go, right, this is what we're looking at, and you choose the starting angle. So you'll notice then I was just saying, right, let's go 20 degrees. Choose an increment that you want to go with. If you go 10 degrees, fine. If you go 5 degrees, fine. If you go 1 degree, I mean, it's probably a bit excessive with 1 degree, but I think 5, 10 degrees, any of them will be perfectly fine to run, because all it will do is it will strengthen any discussion that you have on this assignment. And it really, I'd say, well, I say it's really that simple. It is really that simple, but it's tricky, I do understand. So give me 1 second, I'm just going to stop.